My students and I were awarded a MacBook Cart last year. We were all ready to dive right in and start using the computers. But a cartoon that I saw in another teacher's classroom really gave me a lot to think about. How could I keep the students from reducing the computers to a set of encyclopedias? How could I get them to think for themselves? How could I get the students to create meaningful products? I realized that when I wasn't getting meaningful products, it was because I wasn't asking meaningful questions. So I did some research, and this time, instead of just telling my students all of the answers, I asked them a question. The question is, what is race?
What is race?
What is race?
What is race? What is race?
We already knew that race wasn't biological.
All people are 99% the same.
We're more alike than different.
But it is real.
And it can have an effect on your life. Just because it isn't biological doesn't mean it isn't real.
Trying to answer a question that has more than one possible answer was really challenging for my students. If I had just talked to them about genetics and DNA and answered the questions for them instead of using a framework like what is race, I can guarantee that they wouldn't have been as interested in the content. And if they weren't interested in the content, then they wouldn't have learned as much. But because the question was interesting, students were excited to form groups and were ready to dive right into the research. Some created surveys, others researched the civil rights movement or human migration patterns. Some wondered where the idea of race even came from.
Why do race separates us from other races? Why do they think this way? Why is it important?
Questions like these were the hooks that pulled students into the project. These were the parts of the study that made the biology content meaningful. Because students were interested in answering the question, what is race, they were also interested in studying biology. They explored the structure of DNA. They learned about transcription and translation and how mutations occur. They also compared mitochondrial DNA sequences among chimp races as a way of examining the biological meaning of race. Not only did my students research these topics, but they got to present their findings to their classmates as well. Students told me that they learned plenty of biology while trying to answer our question.
We learned about DNA.
And we learned about how cells make proteins.
We learned about human populations.
And we learned about mutations.
Our project gave the students a way to study the biology content while also exploring history, math, and language arts. While working on the project, the students also had the chance to practice their 21st century skills, like working in teams, and developing and defending their own ideas, and making hard decisions to ensure a clearly focused, well-designed product.
We had to decide what was important and what wasn't. If it helped us answer our question, we kept it.
If not, we threw it out.
The students also gained valuable experience using technology and soliciting help from knowledgeable sources. I'm so glad I finally realized the importance of asking a meaningful question. This experience was powerful for me and my students. They were able to research a provocative question and synthesize their findings to create novel ideas. Because of this experience, I got to hear what every teacher hopes to hear.
I learned a lot.
I learned a lot.
I learned a lot.
I learned a lot.